Our bodies are incredible machines, constantly working to maintain a stable internal environment. One of the most critical aspects of this balance is blood pressure, the force exerted by blood against our artery walls. Maintaining healthy blood pressure is crucial for delivering oxygen and nutrients throughout the body. This is where the Renin-Angiotesin System, or RAS, steps in as a key regulator of this vital life force. This intricate system is a cascade of hormones and enzymes that work together to keep our blood pressure in a healthy range. Think of the RAS as the body's own blood pressure control center. When blood pressure drops too low, the RAS kicks into gear, setting off a chain reaction to raise it back up. Conversely, when blood pressure climbs too high, the RAS can help to lower it. This delicate balance is essential for overall health and well-being. To understand how the RAS works, let's meet the key players in this intricate system. First, we have renin, an enzyme produced by the kidneys. Renin acts like a spark, setting the entire RAS cascade in motion. It does this by acting on a protein called angiotensinogen, which is produced by the liver. Renin cleaves angiotensinogen, transforming it into angiotensin 1. Angiotensin 1, while important in the pathway, is relatively inactive on its own. It needs to be converted to its more potent form, angiotensin 2. This crucial conversion is facilitated by another enzyme called angiotensin converting enzyme, AAC, which is found primarily in the lungs. Finally, we have aldosterone, a hormone produced by the adrenal glands which sit atop the kidneys. Aldosterone plays a vital role in regulating salt and water balance in the body, which is directly tied to blood pressure. Now that we've met the key players, let's see how they work together in the RAS cascade. When blood pressure drops, the kidneys release renin into the bloodstream. Renin then encounters angiotensinogen, converting it to angiotensin. I travels through the bloodstream to the lungs, where ACE quickly transforms it into angiotensin 2. Angiotensin 2 is a powerful hormone that causes blood vessels to constrict, effectively narrowing the passageways for blood flow. This constriction increases blood pressure. Additionally, angiotensin 2 stimulates the release of aldosterone from the adrenal glands. Aldosterone, in turn, acts on the kidneys to retain salt and water, further contributing to increased blood volume and, consequently, higher blood pressure. Section 4. Keeping RAS in check, a delicate balancing act. The RAS is a powerful system, and like any powerful system, it needs to be carefully regulated. Fortunately, our bodies have evolved intricate feedback mechanisms to keep the RAS in check. One of the primary ways the RAS is regulated is through negative feedback. When blood pressure rises, it signals to the kidneys to decrease renin production. This reduction in renin effectively slows down the entire RAS cascade, preventing excessive blood pressure elevation. Besides this internal feedback mechanism, other factors can influence the RAS. Stress, for example, can activate the RAS, leading to a temporary increase in blood pressure. Certain medications, such as ACE inhibitors, can also modulate the RAS, making them valuable tools for managing hypertension. Section 5. RAS and disease. A link to hypertension and more. The RAS plays a critical role in maintaining healthy blood pressure, but when this system goes awry, it can contribute to various health problems. One of the most well-known links is with hypertension or high blood pressure. An overactive RAS can lead to chronically elevated blood pressure, putting strain on the heart and blood vessels. Beyond hypertension, the RAS has been implicated in other cardiovascular diseases, including heart failure and atherosclerosis. In heart failure, for example, an overactive RAS can worsen the condition by increasing fluid retention and putting additional stress on the already weakened heart. Understanding the role of RAS in these conditions is crucial for developing effective treatments. As we've explored, the Renin-Angiotesin System is a complex and essential regulator of blood pressure and fluid balance. Its intricate interplay of hormones and enzymes highlights the remarkable interconnectedness of our bodily systems. By understanding the RAS and its role in health and disease, we can better appreciate the importance of medical interventions, lifestyle modifications, and ongoing research aimed at keeping this vital system in balance.